Carbon-14 dating assumes that the carbon dioxide on Earth today has the same radioactive content as it did centuries ago. If this is true, then the amount of carbon-14 absorbed by a tree that grew several centuries ago should be the same amount as the amount of carbon-14 absorbed by a tree growing today. A piece of ancient charcoal contains only 15% as much radioactive carbon as a piece of modern charcoal. How long ago was the tree burned to make the ancient charcoal, assuming that the half-life is 5,715 years? Okay, there's a lot going on in that paragraph. The first thing we need to do is come up with an exponential model that represents how carbon-14 decays. So we know that y equals a times e to the bx, right? Because it's decaying exponentially. Well, we know at time 0, there's going to be 100% of that carbon in the tree. So we have 100 equals a times e to the 0, so a equals 100. So now we know y equals 100 e to the bx. Okay, the next thing we know about carbon is it has a half-life of 5,715 years. So that's y of 5,715 will be 50% of the carbon left in the tree. So that means 50 equals 100 e to the 5715b. Now I can solve for b. Dividing by 100, 1/2 equals e to the 5715b. Now I can use inverses. ln of 1/2 equals ln e to the 5715b. This ln e cancels. So now I have ln of 1/2 equals 5715b. So b equals ln of 1/2 divided by 5715. And if we check this in our calculator, we'll see this is less than 0, which does show that it is decaying. So now our formula is y equals 100e to the ln of 1/2 over 5715x. So they're telling us that they found a piece of ancient charcoal which only contains 15% of that radioactive carbon. So we know that y of some time is going to be 15%. Okay, so let's see, what is that time? How long did it take for it to decay to 15%? So I have 15 equals 100 e to the ln of 1/2 over 5715x. I need to solve for x, which is actually going to be our time in this instance. So if I divide by 100, I have 3 over 20 equals e to the ln of 1/2 over 5715t. Now I can use inverses. ln of 3 over 20 equals ln of e to the ln of 1/2 over 5715t. This ln e is going to cancel. So now I have ln of 3 over 20 equals ln of 1/2 over 575t. So in order to isolate t, I need to multiply by the reciprocal of that fraction. So t equals ln of 3 over 20 times my reciprocal, 5715 over ln of 1/2. Now I can plug in to my calculator. T is approximately 15,641.758. So we know that this tree burned about 15,641 years ago. And just so you know, your textbook likes to round. The textbook answer would be 15642 years ago. I would accept either answer.